For this lab, experiment 4, the objective is to become familiar with the acid-base properties of buffers. Okay. So remember in the lecture, the definition of a buffer is a solution that can resist changes in pH upon the addition of acid or base. Right? You will study the property of two buffers in this experiment. One is acetic acid and the sodium acetate buffer, and the other is ammonia and the ammonium chloride buffer. And you will determine which buffer solution is the best when you add HCl or sodium hydroxide. Okay. So experiment will be two parts. First one is to work with acetic acid and the sodium acetate buffer system. We'll determine the pH after we add HCl and the sodium hydroxide. And the second part of the experiment will be prepare the ammonia and ammonium chloride buffer system, and we'll determine which buffer is best in terms of resisting pH change. Okay. Okay, so let's look at the first one. We'll use acetic acid. So this is 0.1 molar acetic acid and 0.1 molar sodium acetate. We use graduated cylinder, add 20 ml of 0.1 acetic acid and 30 ml of 0.1 molar sodium acetate together to form this buffer system. And after the solution mixed, and we can use this pH meter. I'll show you how to use the pH meter in the later part of the slides. Okay, we use this pH meter, so we just stick the sensor into the solution, and that can read out the pH value. So for this buffer, the readout value is 4.88. Okay. So you will be provided with concentration and volume information in your template. And then you will need to calculate the pH for the buffer based on the pKa and based on how much acetic acid and sodium acetate is added. And then you will calculate that pH, and then you will compare that pH with the measurement pH. So you will be given that measurement to be 4.88, and you can compare the absolute values and determine the percent error. So making this buffer and then calculate the pH and compare the measurement with calculation. Okay, and then because remember we use 20 plus 30, so that's a 15 ml of the buffer solution. And now we separate that into two 25 ml volumes. And to one of the 25 ml, we add 5 ml of 0.1 molar hydrochloric acid. And then we measure the pH. And that value will be given in the template. And the other half of the solution will add same amount, same concentration, but the sodium hydroxide. And there's a strong base, there's a strong acid. So then we'll measure the pH, okay? And we'll calculate the theoretical pH for adding the strong acid and for adding the strong base. And then compare that with the experimental result. So the experimental results will be given to you in the template, and then you need to calculate the pH based on the volume and the concentration that's added. So this value will be also provided in the template. So after the HCl addition, the pH dropped Remember, it was initial pH was a 4.88, and after you're adding HCl, the pH dropped to 4.49. And after you're adding sodium hydroxide, the pH apparently increased to 5.35. So it's become more basic, and here become more acidic. So there is a video on Canvas. Now you should see my screen showing the Canvas page. There should be the experiment 4 materials, instruction materials. I include a few videos there, so it'll just show the pH trace after adding either HCl or adding HCl to the acidic buffer or adding HCl to ammonia buffer. I'll just show one of them in class, so you can watch the rest after class. Okay. This one. Okay, so this is the one that's showing that from the original pH was close to 4.88, so it's close to 4.9 there. And at some point, we add the HCl, and then the pH drop. We'll just show that trace. So the pH meter can record, so horizontal is the time, the pH meter can record the pH value over time. So we'll see that. So stable before I add any HCl. So it's got some fluctuations. It's because the instrument reading always have some noise. And at that point, we began to add HCl. So you can see the pH drop a little bit. So that's not because of the measurement noise, electronic noise. So that's because the HCl addition there. And then after that, the pH is stable at another value that's close to 4.5. Move this so fast up. So basically, that shows over time it's stable at around 4.5. So the only change there is because we add the HCl. In comparison, we want to add the same amount of HCl and the same amount of sodium hydroxide into 25 ml of water, respectively. This amount of HCl is added to 25 ml of water, and this amount of sodium hydroxide is added to 25 ml of water. And it's just pure DI water. There's no chemicals in it, and we will measure the pH. And there is also a video made showing the change of a pH after HCl is added. The change in pH is a lot larger than the change of pH in buffer solutions. So here you need to answer, is water a good buffer compared to the acetate buffer solution? These will be provided to you in the initial pH. So for the buffer solution was a 4.88, and the water is 6.89. So you would expect the water to be 7.00 because it's a neutral, right? However, when the water comes out of that tap, it got a contact with atmosphere. Carbon dioxide in the air, so the carbon dioxide we breathe in and out can be dissolved in water. That just form carbonic acid, so that make the water a little bit acidic. You can see that, right? So after we add the acid, then for the buffer solution that dropped to roughly 4.5, and after adding the base, the buffer solution pH increased to 5.35. So it's roughly dropped about let's say 0.4 after adding acid, increased also about 0.4 after adding base. However, for water, just look at these values. So after the same amount of acid, the pH dropped about more than 5 units. Okay, and after adding base, that's increased about 5 units there. So it's a lot more significant increase or decrease compared to the buffer solution. You will calculate the theoretical prediction of the pH, and then you need to make a comparison to these measurement values and calculate the percent error. The second part will be the ammonia and ammonium buffer system, and we'll use 3 different buffers and determine which one's the best. So the first one we will mix with ammonia with ammonium chloride solution, and the second one we will use ammonia, and ammonia, that's a solution, together with a solid ammonium chloride. And the other way is to use ammonia, and we will titrate that with HCl. The HCl will react with ammonia to form ammonium chloride. The first case still use the graduated cylinder to prepare the buffer solution out of these 2 solutions. For each buffer, we use 1 mole of HCl to add to each buffer to the point the pH will be reach 8.00, okay? And for each buffer, we will also add sodium hydroxide to reach pH of 10.00. And in the next table, I'll show you how many drop in this table. That's how many drop that's needed for that buffer to reach a particular pH based on the number of drops. Which one is the best buffer? You should be looking at which buffer system takes more drops, right? Means it has more resistance to any other acid or base added to the solution. So you will be looking for which one has more drops, and that will be the one that's the best buffer. So in this experiment, we use the linear pH meter. This is a procedure how to use it. First, to turn it on, it's just basically like a handheld device. Okay, it has battery inside, so we turn it on, and the screen should show up, and it should show up some random values. And before we first use that to measure a pH value, we need to calibrate the sensor every time before we use it. You'll be provided with 3 different buffers, and you can use 2 of them to calibrate the pH meter. So in this case, we'll use 4 and 7. Once we have this open up, we'll tap on the sensor, and there's a calibrate. We'll tap on calibrate, and because it has multiple channels, and we only have channel 1 attached, we'll do channel 1. And after we tap calibrate now in channel 1, and we can insert the sensor into the pH 4 buffer solution, and then we'll enter 4.00. And then after that, we'll rinse the sensor and wipe it dry and stick it into another buffer solution. So we use a pH 7 and repeat that process, enter 7.00. And then after that, tap keep. So the calibration will be saved, and the pH meter will be ready to use. In here, a lab report template with observations will be provided to you. You will see data in table 1, table 2, and there is also experimental procedure that you can follow what's done in the lab, and there will be an example calculation in the experimental procedure, so you can see what kind of a calculation is needed. You will need to download the lab report template and do the calculations and answer the questions about the ammonia-ammonium buffers.